Okay, this is the audio amplifier, project 4. And there is the power section of our schematic. For circuit theory, there is the voltage divider using those two resistors. And Kevin,
yep. All right. So, we have a little LED indicator there. Powered. So basically, we have 9 volts here, and it's broken up into about 4.5 here and 4.5 there. This is V plus and V minus. This is our virtual ground. The capacitors help to supply power to for transients, for sort of a peak demand. And then this is based on the amplifier section itself is actually based on 2 dual op-amp circuits. This one is the 747, LM747, and this is a 1458. Now in this configuration, we have each one forms an inverting amplifier, and the gain on an inverting amplifier is controlled by the feedback resistor divided by the input resistor. And in our circuit, this is a 100K maximum potentiometer, and this is a 10K. So the maximum gain value is 10. But the output, of course, is the negative of the input. And so we have this next stage to flip the output and come up with basically the original signal, only amplified by our gain factor. And the gain on this circuit is 1. So these 2 resistors are the same values. And then finally it goes to the output. Now the reason why we use the second stage, we could have used some type of non-inverting amplifier or something like that, but we wouldn't have been able to get a true ratio from 0 to 10. Also, this stage is able to supply more power to the output, so it's sort of like a buffer, and that's really what this forms, is a buffer.
Okay, this is all in fast motion, and this is Kevin soldering more flexible wires onto the LED.
The circuit took 6 hours to finally put together on this board. I recommend making your own PCB.
Yeah, that's probably a good idea.
And be very careful. We decided to use resistor networks in this project. It's a group of 5 resistors together. If you overheat them, they will become short circuits.
Yeah, and that sucked. And then here we're covering the wires to try and prevent short circuits and anything else bad from happening.
Right, because the case in this, in our case, is grounded.
Case in our case, nice.
Indeed.
And then here we are attaching the case to the bottom to make the circuit grounded. And then we're putting it in, which is a lot harder than it looks. And we kept discovering that certain things were conductive and interfered if they were touching ground. And that's Kevin on the guitar, by the way. And that's an Altoids 10. And there I snapped it to get the switch in, because Kevin couldn't do it. And now we're gluing in the external input-output jacks. And then there are the input. I guess I may have misspoke.
Yes, the jacks only do 1 at a time.
Yeah,
and
but
these are special input and output jacks that have a switch that is open whenever you insert something into the jack, allowing us to get input and output either by the cables or the jacks, but not both at the same time.
Yeah, I misspoke and said jacks when I meant the cables. And then there he is grounding those to the tin. Then placing in the battery. And that's it. Alright, so when the iPod is turned on, there is some audio bleeding through before we actually turn it on, and that's one possible drawback.
So you notice as I turn the knob, the volume increases. What I'm doing is increasing the feedback resistance, which increases the gain of the circuit, thereby making it louder. And then I turn it back, it gets quieter. There's a balance where it's loud but not distorted that you have to come to. But for most applications, the circuit's adequate.
Yeah.